What is up, my people? This is Mr. Tui, creator of the Accuplacer Math Crash Course series. And if you're looking for Accuplacer Math Test Prep for the Advanced Algebra and Functions section of the Accuplacer test, you are in the right place. In this video, I'm going to teach you the easiest way to solve a variety of questions from the Advanced Algebra and Functions section of the test, using my unique and powerful test-taking strategies that simplify the questions. Oh, and by the way, if you like this video, you definitely want to access the full version of Accuplacer Math Crash Course. It includes over 13 hours of the best Accuplacer math instruction available anywhere. Just click the link in the description below to access the full version of the course. In the meantime, enjoy these answer explanations from the Advanced Algebra and Functions section of the test.
Go ahead and read this question for us, please.
So 3 to the second plus 25x minus 18. Which of the following is a factor of the polynomial above?
Ooh, which of the following is a factor of the polynomial above? Let's talk about factors. You know what a factor means?
Yeah, like, I don't know if it's kind of hard for me to explain. I just know how to do it.
Okay, yeah, I got you.
Like, you factor out, you factor in.
Yeah, absolutely. You're familiar with it. So what a factor is, it means it's a number that you multiply with another number, or a term that you multiply with another term to get another term. So like, let's look at, I'm going to get real concrete with an actual value. 12. If we talk about the factors of 12, what are the factors of 12? Well, you can multiply 3 times 4 to get 12, right? So one of the factors of 12 is 3, and another factor is 4. Okay? You could also multiply 1 and 12 together to get 12, right? Because 1 times 12 is 12. So another set of factors of 12 is 1 and 12. So you could say these are all factors of 12. 3, 4, 1, and 12 are factors of 12. Numbers or terms that you multiply together to get 12. Does that make some sense?
Yes.
Okay. I mean, you do the same thing with like 16. What are the factors of 16? Well, obviously 4 times 4 is 16. So we've got 4 is a factor. But you also multiply 2 and 8 to get 16. So another factor would be 2 and 8. And of course, 1 times 16 is also 16. So 1 and 16 are also factors. In no particular order, clearly. Right there. But those are all factors. Numbers that you can multiply together to get 16. Does that make sense?
Mm-hmm.
Okay. So there's a way to sort of factor this like algebraically, and it's super annoying, it's super complicated, and you don't need to know it for any of the factoring questions I've seen on the Accuplacer. So I'm going to teach you the trick, which is turning it into basically arithmetic with plugging in values. Okay?
Okay.
I'll show you what that looks like. On all the factoring questions I've seen, you can do this. All right. So I'm going to create a value for x. I have not abandoned the plugging in values strategy. Still works. So we're going to create a value for x. X is 1. 0 might work, I don't know. But we're going to do, that might be even easier. We're going to start with 1. All right. All right, so if x is 1, what does this expression in the question equal? Okay, well, let's just plug in values. So it's 3 times 1 squared plus 25 times 1. Minus 18. Let's simplify this, and this will be a good PEMDAS review. Can you talk me through this? How would we simplify this?
Okay, so
what does that equal right there?
You do your exponents first, right?
Yep, exponents first, absolutely. Maybe you can work this out. Let me see you simplify this.
Okay.
So do those exponents first, absolutely. Absolutely. Perfect. I'm going to stop you real quick. You did this beautifully. I'm so glad you didn't square the 3 here. I'm so glad you didn't, right? Because 3 is not being squared. It's just the 1 that's being squared. And what's 1 times 1?
1.
Just 1. So that's 3 times 1, which is just 3. Beautiful. And of course, 25 times 1 is just 25. So great job there. I just want to go over that sort of that PEMDAS order of operations there. A lot of students want to square that 3. It's not going to be 9. It's just going to be 3 on the left-hand side. All right, so what does that give us, by the way?
10.
So that's going to get, it's going to be 3 plus 25 is 28, minus 18 is 10. Absolutely. Okay. So when x is 1, when x is 1, this expression in the question is 10 when x is 1. Okay, great. Now the question is, which of the following is a factor of that polynomial? But when x is 1, that polynomial, that expression is 10. So really, now we've turned this into an arithmetic question. We're saying which of the following is a factor of 10? That's all we're finding now. Which of the following answer choices is a factor of 10 when x is 1? Does that make some sense?
Wait. Can you say that again one
So,
time?
yeah. So the question is saying which of the following is a factor of that polynomial expression, this big expression up here with the x squared, just 3x squared plus 25x minus 18.
All right.
But when x is 1, that expression equals 10. When x is 1. So we've turned this question now into which of the following is a factor of 10
Okay.
when x is 1. Right? And then we're just going to plug in that 1 for x into the answer choices and see which of those answer choices is a factor of 10. Okay? It's going to make, that needs to make more sense as we do this, as we test these answer choices. So let's plug in a 1 for x in answer choice A. What does that give us? When x is 1, what does that give us for answer choice A?
It'd be a negative
It's going to be negative for sure. It's 1 minus
Negative
9.
8.
Negative 8, absolutely. That's negative 8. Okay. Is negative 8 a factor of 10? That's to say, can you multiply negative 8 by something to get 10?
No.
No way. No way. So A is gone. Does that make sense?
Yes.
Beautiful. Let's plug in that x1 into answer choice B. Now that's 1 plus 3. What's 1 plus 3?
4.
4. Is 4 a factor of 10?
No.
No. You can't, well, I mean, you can't multiply 4 by some whole number at least and get 10. Right? Because 4 times 2 is 8. But that's less than 10. And then 4 times 3 is 12, and that's bigger than 10. You can't multiply 4 times some whole number and get 10. So we can also eliminate answer choice B. Make sense?
Yes.
All right. All right. Let's try answer choice C.
That's 1.
That's 1. Is 1 a factor of 10?
You can do 1 times 10.
You do 1 times 10. 1 is a factor of 10. That's true. So we'll keep answer choice C. What about answer choice D?
No, that's 4.
That's 4. It's 4 a factor of 10. Is 4 a factor of 10?
Oh, no.
No way. Yeah. Answer choice C. All right, so basically what I'm doing here, we're just going like concept by concept in the sort of advanced algebra and functions section of the Accuplacer. That's all we're doing here. So there's just some real specific concepts like factoring, like the equation of a circle. And functions, which we've talked about a little bit, I believe on day 4, part 2. We talked about functions a little bit, but I want to get back to them, okay? Because you're definitely going to see some functions questions on the Accuplacer, and I want to really have this down, so I want to spend some more time on functions right now. Go ahead and read this question for me. We'll talk about functions in general, and I'll show you exactly how to solve this.
The function f is defined by f of x equals... Did I do that right? F of x? I think I did. Okay.
Perfect. F of x,
Equals-
perfect. Yeah.
Equals negative 2x plus 6. What is the value of f times 10?
So that's actually read f of 10, right? Just like up here is
Okay,
f of x. Yeah. No, I mean, and I get, like a lot of students think you're multiplying f times 10. That's not what it means. This is function notation. Okay, and we're going to review that here in just a moment. I think previously I gave you an example of a real simple function. I'm going to do the same thing here. This is worth reviewing. Okay, this is worth reviewing. If we had a function like this, f of x equals 3x plus 1. Okay, there's a function. And function notation throws a lot of students off. They're like, f of x, I don't know what to do with that. Okay, don't even worry about that. It's basically the same as, it's the same as the equation y equals 3x plus 1. It would graph the exact same way on the xy axis. It's the exact, in fact, f of x and y are interchangeable. Sometimes I just describe f of x as fancy y. Okay, so it's the same concept, just a different way of writing it out. But I'll show you why function notation is actually kind of handy. Okay, if I said find f of 2. Okay, find f of 2. All that means is where there was an x Now there's a 2 in the function. So you're replacing all the x's with 2's. That's it. So what's f of 2? It's just going to be 3, not times x, but times 2 plus 1. Does that make sense?
Yes.
Literally, all you've done is you've taken where there was an x, you've replaced it with a 2. A question like this is really a breeze once you understand the concept of a function, what function notation means. So I could say f of 2 equals, and I'm just going to simplify this, 3 times 2 is 6 plus 1 is 7. So f of 2 is 7. Does that make sense?
Right. Yes.
Okay. So when your input, and this is how I recommend thinking of functions, x is your input. So when 2 is your input into the function, your output is 7. Inputs and outputs. X is your input, f of x is your output. Or f of 2, or f of 3, or f of 4 is your output. For whatever that input x is. Okay? Let's do it again. Again, this is just so, it's, you know, you're probably going to see a number of function questions. I just want to really get this down. Let's find f of 4. What's f of 4? In fact, I want to see you work this out. Can you show me what is f of 4?
Okay.
Go and work that out on the whiteboard.
Do you want me to write the 4?
Yeah,
Like,
yeah, I just want to see. Yeah, I want to see. Plug it in. Great. Looking good. Looking good.
Oh.
Great. Excellent. So you would say f of 4 equals 13. Exactly. Exactly. That's it. That's it. Another way to express that is basically like when your x value is 4, your f of x value or your y value is 13. Your f of x value or your y value, same thing. F of x is just fancy y. So you could graph that the same, that point on the xy axis. That would be the point 4, 13 on the xy axis.
Okay.
Okay. And I've got that on the rules for Accuplacer Math real quick. I do want to go over functions again. Somewhere here. Where are my functions? There we go, basic concept F. This part right here. Understand x is the input, f of x is the output. And then understand f of x is fancy y, especially if they give you a graphing question with functions. Whatever your f of x value is, just make that your y value. It's the same thing. Okay, and we'll practice that. All right, so let's go back to the question at hand. I just want to review what functions are and how they work. Just understand them in terms of inputs and outputs. Read the question again one more time for me, because I think this question is actually really, really easy if you understand what functions mean. Go and read the question, please.
The function f is defined by f of x equals negative 2x plus 6. What is the value of f of a... I can't even do it.
You got it. F of 10. You got it. You got it. All right. You know how to do this. Where there was an x in the function, now there's a 10. Let me see you plug it in. That's all it means. That's all it means. Absolutely. Looking good, looking good. Great. All right, let's simplify it. Just PEMDAS here, right? We don't need, there's nothing calculated in parentheses, no exponents. Do that multiplication. Beautiful. Beautiful. Come on. What's the right answer here?
A.
Answer choice A. Bingo. Oh, I just erased it. Oh. There we go. Beautiful. Easy if you know what function notation means.
Yes.
Does that make sense?
Yes.
Don't be intimidated by it. Just find out whatever is, in the parentheses, that's your input. So 10 is your input for x. It's a plugging in values question disguised as a function question. You're just plugging in 10 for x. Okay?
Okay.
All right. Let's do some more functions. All right. I like this one. This one's funny. It looks really scary. It's not. Go ahead and read this one for me, please.
We have f of x equals x to the second plus 3x plus 1. What is... How do you say that? I have to say
f of x plus 2.
f of x plus 2.
Remember in the last question, right, where we were finding f of 10?
Mm-hmm.
Remember that? And I said, whatever's in parentheses, that's your input for x. Okay. Same thing here. What's your input for x? What's your input? It's a thing in parentheses.
The x plus 2.
X plus 2 is your input. Absolutely. So where there was an x, now there's just an x plus 2. So plug it in. Plug in x plus 2 in place of x into this function right here. Does that make sense?
Yes.
All right. Let me see you do that. Looking good, looking good. Looking great. Where there was an x, now there's x plus 2. Magnificent. All right, I'm going to stop you real quick. Because the temptation is to like multiply all that out, like FOIL that x plus 2 squared, distribute that 3 times x plus 2. It's very tempting to do that. But I want you to look at the answer choices real quick, Keisha. Tell me what the right answer is right now.
B.
Answer choice B. It's exactly what you have here. All they're testing you on is if you have that concept of inputs and outputs straight. That's all. That's all. Where there was an x, there's now x plus 2. That's it. Any questions about that?
No, sir.
All right. All right. Inputs and outputs. Just keep your inputs and your outputs straight and you're good. These look like scary questions. This one here especially looks very scary. But it's not bad. Go ahead and read this question for me, please.
What is an equation of the graph shown?
Okay. Okay, now this is a funky curve here. Okay, funky curve. This is a graph of an exponential equation. Okay, you get funky curves up for, we're talking about exponential increase, or a funky curve down if we're talking about like exponential decrease. Okay. And notice in the answer choices, by the way, all of the answer choices have x raised to a certain power. Or sorry, all the values are raised to the power of x, I should say. That's why it's called exponential or exponential growth. It's because x is an exponent here. Okay.
Okay.
Now, just looking at the answer choices, like I don't know how to graph any of those. Okay.
Right.
And it's sort of like in the way you can just sort of like use, slope and the y-intercept to do y equals mx plus b. It doesn't work like that with there's no trick to that, like that with exponential equations. But let's look at this graph again. let's look at this graph right here. Anytime they give you a graph, they're giving you a bunch of x and y values that you can always test. A bunch of x and y values. For example, I know when x is 0, for this equation in the graph, when x is 0, what does my y value have to be?
0?
No. No, when x is 0, what does my y value have to be? In the graph.
Looking at the graph, 4?
It's 4, absolutely, right? It's that point right there, right? 0, 4. Does that make sense?
Yes.
Okay. I know that when x is 1, what's my y value have to be?
Oh, 8.
8, absolutely, right? Because that's the point right there. That's the point, 1, 8. So when x is 1, y has to be 8. When x is 2, what's my y value have to be?
16.
16. That's the point right there, 2, 16. Does that make sense? Why I say you've got like a bunch of x and y values you can sort of test.
Yes.
Okay. So all we got to do now is take those pairs, and I don't know how many it's going to take here, but plug those into the answer choices. And the right answer has to give us a true statement for all those. And we've got more if we need to. We can plug in 3 and 32 if we need to. Okay. Let's start. Go ahead. What's up?
No, I'm going to solve it. It probably answer my question.
Okay. Okay. Well, let's do this. Let's start with 1 and 8. Okay, because you know what things to the power of 1 are, right? What's, like, for example, what's 2 to the power of 1?
2 to the power of 1, 1.
What's 2 to the power of 1?
1.
No.
Oh, 2.
It's just 2, right? Yeah, it means 2 one time, basically. 2 to the power of 2 is 4. 2 to the power of 3 is 8, right? Is that familiar? Kind of how those exponents work? Okay. The reason why I was tempted to plug in this 0 and 4 pair right here, and we could do that. I mean, it would totally work, but students get tripped up on things to the power of 0. Things to the power of 0 throws everybody off. We might come back to it. I might address that here in just a minute. But things to the power of 1, anything to the power of 1 is itself, right? So 2 to the power of 1 is going to be 2. 4 to the power of 1 is going to be 4. 8 to the power of 1 is 8, etc. Okay. All right, so let's do this. Let's plug in our x and y values into answer choice A, and let's see if we get a true statement. Okay? So we're plugging in a 1 for x and an 8 for y. Can I see you work that out on the whiteboard?
Well, does that look like an 8?
You're good. I can tell it looks close to an 8. Okay.
Oh, I see what you're saying.
All right. You're right. 2 to the power of 1 is just 2. So is that a true statement?
No.
No. And we know the right answer has to give us a true statement because we know when x is 1, y has to be 8. It's on the graph. So answer choice A is gone. Make sense?
Yes.
Great. Let's do the same thing for answer choice B. Let me see you plug in that 1 and 8 once again.
That's not true.
That's not true. 8 does not equal 4, last I checked. So answer choice B is gone. This is not bad, is it?
No.
No. Once you realize, again, anytime they give you a graph, they're just giving you a bunch of x, y values to test. It works for parabolas, heck, works for lines, clearly works for this funky curve here, this exponential equation. Works for anything on the x, y axis. Okay. Circles, for that matter, it works. All right. Answer choice C. Let's try that. I'll clear some space.
Oops.
All right. Yeah, 8 equals 8. That looks good. Let's keep C. And we'll try answer choice D. I'm not going to lie, D's looking pretty good too. Okay, 8 equals 8 there as well. So C and D both work. Okay, you tell me right now, Kiesia, you tell me, what do we do now? Because it is either C or D. You know, I guess
use a different value.
you'll plug in a different value. Yeah, absolutely. Let's plug in a 2 for X and a 16 for Y. Let's do that.
Oh.
Again, if you're really comfortable with 0 as an exponent, you can plug in 0 and 4. That would be totally cool. We're going to do that here at the end. But start with 2 and 16. And we're just plugging them in. A and B are already gone, so we don't have to worry about A and B, so we're just plugging them into C and D. Do you know how to increase the width of your pencil on the whiteboard? Do you know how to do that? I just want to make sure this is showing up for everybody. I can see. I just know anybody working on a phone might have a little trouble seeing those lines. You know, increase the width a little bit. Just click on the pencil and then scooch over the width. Yeah. There you go. Oh, much better. Much better. It's great. Great. Okay. So let's PEMDAS this here, right? You got 16 equals 2 times 4 to the power of 2. How do we simplify this with PEMDAS?
You're doing exponent first.
Exponent
so
first.
That gives me 16 times 2.
Excellent. 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 Is that a true statement?
Oh.
No, right? You're going to get 32 on the right-hand side, not 16.
Right.
So C is gone. Let's try answer choice D. I'll clear some space again.
Oh, why did I do that?
You're good. Yeah, right? Absolutely, right? Because 2 squared here is 4 times 4 is 16. Absolutely. So you get 16 on the right-hand side, 16 still on the left-hand side. Answer choice D. Bingo. Any questions about that?
No.
Okay. All right. I mean, it looks like they're testing you on exponential equations, which kind of they are. But again, you can use that plugging in values strategy, which is so freaking handy. So handy.
I hope you guys enjoyed those answer explanations from the Advanced Algebra and Functions section of the test. Now don't forget, if you like this video and you're serious about passing the Accuplacer Math Test, then you definitely want to access the full version of Accuplacer Math Crash Course. Just click the link in the description below to access the full version of the course. Nobody makes it easier for you to pass this test. So click the link in the description below, access the full course, and I'll see you guys on the inside.